we'll do the question time based key value store. So the question says is we have this constructor that will initialize a map, and then there's a set and get method. So set method will go and put up this value against this timestamp for this key, right? So this is simple. And for the get method, whatever timestamp we have given, we have to return the value for that particular key on that particular timestamp. If that timestamp is not there, we have to give the closest timestamp. So if current time is 3 and we don't have 3, and but we have 2 4, so it should return 4, because till time 3 we have seen 2 and 4 is still not yet seen. Okay, I'll take an example to understand this. Suppose for the same key, suppose, okay, for the same key, suppose there is a key A, okay, and against this key we have the values 1, suppose 1 is AA, 2 is AB, 3 is not there thing, okay, and 4 is AC or AD, okay, and we have to figure out for key A time 3 what is the value we have seen. So if we do it like go one by one, then this will take O of n, but we want to do better, we want to do log n, so that is binary search. So what we will do is, suppose we will take L and R. So now L is here, R is here, okay, and we'll check the mid. So this is the mid guy, okay. Now whatever mid guy comes up, we'll check, okay, what is the timestamp. If timestamp anytime becomes less than equal to, so 3 is less than equal to 2, right? So we will update, we'll keep answer variable and we'll say, okay, AB is the answer for now. Next we'll update, okay. So now we'll update mid, so that will be L plus 1, so L will also come here and R is also here, right? So this time the value is 4, right? So but 4 we cannot take, right? We cannot update mid because 4 happens after 3. So in that case, no need to update the answer. We'll simply say right equal to mid minus 1, right equal to mid minus 1. In that case, right will come here. Okay, so this is the mid, right will come here, and left and right has crossed. So the search will be over. Simple. So now we already have the key value store. When we set, we'll check, okay, if let's copy this guy. First we'll check if the key is there or not. Okay, if the key is not there, then means this is the first time, right? So for the first time we'll say, okay, go for this, okay, and we have to get the key and we have to set it, right? So we'll say dot get key. Okay, first of all we have to set it, right? We have to set this key with an empty array, okay, because we have to save value and timestamp both, right? So we have set it. Now once we have our array in the key, we'll say this dot key store dot get this particular key, and in that key go and push this timestamp with the value given. Okay, so we have set it perfectly. So we got the just right to this code. So we checked, okay, if the key is not there, then go and put a array in that for that particular key, right? Now we got the key that will return us this empty array, and inside this empty array push this pair timestamp and value. Okay, now when we do a set, now next time when we do a set, we have to check, okay, suppose even the key is not there, right? If the key is not there, there's no sense for timestamp. So let's check that first. If this dot key store dot has, if this has this key, okay, if you put a not, this becomes, if it does not has the key, you can simply return an empty string. This is what has been told in the question. But if it have the key, then it means it can directly have the key, or it can have a number lower than that of the key. Okay, So first of all, what we need an answer variable. Okay, and then what we need for that key, what are all the values, right? Because on all the value set we will get the, we'll do the binary search. So we'll say let values equal to this dot key store dot get this key for me. Okay, once we get the values, we need the pointers left at 0, right at values dot length -1. Okay, let me make the code a bit bigger. Now we'll start. Let's say while left is less than equal to right. What we have to do, we have to figure out the mid. So let's get the mid. Const mid equal to math dot floor right plus left by 2. Okay, once we got the mid, we will check whether the mid is in which range, right? So if values mid, okay, this is what we'll get. If values of mid, and where is the timestamp is at 0, correct? Timestamp is at 0, is less than equal to timestamp, then this means we have find a closer value, okay, to the timestamp. So let's update the answer with again values mid, and the actual value is at 1. Okay, if not, that means the mid is and also we have to update left equal to mid plus 1, right? Because now we need a much more closer value between mid. Okay, much more closer value. Okay, now what we have to do is, now suppose whatever mid we figured out, okay, that mid is exceeding timestamp. Okay, that mid is exceeding timestamp. So basically, so suppose here the mid was 3 and the mid was 3 and the timestamp required was 8 suppose, right? So that's why we do mid plus 1. So next time will search from 4 to 8, right? But here the condition is the mid is again, suppose mid is 4 and the timestamp required is in this side, right? So we have to move the right pointer to this mid -1 guy to check the left portion. So here we'll say, okay, no need to update the answer, simply do right equal to mid -1. And once this is done, if it finds any answer, it should be saved the closest one in this guy. We can simply return answer. Okay, let's run it. Accepted, submit, done.